In this lesson, we will discuss logistic regression or binary classification. Here I have written some information, but before going to discuss, I will give some background of what we are going to discuss and what is the difference between logistic regression or linear regression. Linear regression we have discussed earlier, but quickly I will explain it again. So see here we have two columns, area and price. So you can see if the area of the house is 2500 square feet, the price is half million. If the area of the house is 2800 square feet, the price of the house is 550K and so on. So simply we can say that price depends on area. As the area of the houses increases, the prices increases. But when we make a graph between these two variables by taking area, which is the independent variable on x-axis, you can see that 5 or 6 points will be on a straight line if I will make a line like this, right? So it means that there is a positive relationship between these two variables, not 100%, because each and every point will not be on the line. The relationship ranges -1 to +1. So it means there is a positive relationship, maybe 90%, 0.90, 0.85 and so on, but still there is a positive relationship. And we use y is equal to mx plus b for the linear regression equation. Y is the independent variable, which is equal to m is the coefficient, x is the independent variable, and b is intercept. If this is not clear, so I recommend please watch my video. I will also provide the link in my description as well. So the very simple, you can say that dependent variable in case of linear regression are continuous in nature. And here are the stock price, example weather price. These are the dependent variable, means stock price depends on the economy, so economy is the independent variable. And when we will make the model, so predicted value is continuous in the case of linear regression. Now we will talk about the logistic regression, which is also called logit regression. Though the name says regression, but it is also called a classification. It works for as a classifier, so used for classification, and it also helps in decision making. Now what is the meaning of use for classification? I have mentioned here there are two types of classification problems which we solve with the help of logistic regression. One is called the binary classification, which is our topic, and second is multi-class classification, which we will discuss later on, right? So binary classification or binomial means which gives the output in the form of 0 and 1. Only there are two outputs, 0 and 1, true and false, yes and no, right? Success or failure. True means 1 and false means 0. Similarly, yes, y or s means 1, n and f means 0. And it also helps in decision making, right? When we have some problem in some situations, so we make decision by using the logistic regression in Python. One of the most important feature is that they in logistic regression uses probability, and keep in mind that probability ranges between 0 to 1. Whatever is the circumstances, we have to create the best model for dependent and independent variable, while independent variable may be continuous or binary. Now the question arises where we use the logistic regression in machine learning. We use logistic regression in machine learning, and predictive value is categorical. In case of linear regression, predictive value is continuous, while in logistic regression, predicted value is categorical. Right? I will show all this with the help of example in my Python. This is just the background I am going to show, and this example we will use in our Python coding. So see here we have two columns, age and insurance. So if suppose the person is 18 years of age, if I will ask him or her whether you want to buy a life insurance or not, maybe he will say no. 21 years, no. 0 means no, 1 means yes. If the age is 37 years, maybe he will say yes, so yes. Right? If you will see this pattern, you will see that the young people usually do not buy the insurance. As the age increases, the people buy the insurance. If I will make the graph by using these two columns, right, so I will get this type of graph which I will show you here. See here, 0, as I told you that here we use in logistic regression, we use probability, and the range is between 0 to 1. 0 means they do not buy insurance, but here is some outlier as well, right? Maybe at the age of 60, he does not want or she does not want 50. And here are, as the age increases, if you will see, as the age increases, people usually buy the life insurance. Now, if I will make the line here, hardly you can say 1 point will be on the line. So we cannot make any prediction, right? So in this case, the graph is, if I will join all these points and then come down and join all these points, more or less our graph will be just like this, S shape, right? It means these are outliers. Now the question arises, how we make this graph? So here is the term or the topic which we use in statistics, which is sigmoid function or logit function. If you have a time, you can read about the sigmoid function, but quickly I will explain to you that sigmoid, in some books you will see they have used letter P here. Some books they are going to use Z, but actually this is the probability, which is equal to 1 divided by 1 plus e raised to power minus z. This e is called the Euler's number, which is equal to 2.71828. What actually this formula sigmoid function does, it converts the input into 0 and 1, which is 0 to 1, which is the range of probability, right? But instead of this minus z, what you have to give here, you have to use this y is equal to mx plus b, the value of this, which we usually get by using the linear regression. So this is all about this topic, which we are going to discuss. When we will make the 2D graph by using this sigmoid function, we will get this type of graph, right? Okay, now we will, but this one you do not have worry about this, because everything will be so easy if we will do some coding in Python, right? So here I have written the same information, that usually there are two types of machine learning problems: linear regression, where prediction value is continuous, and classification means logistic regression, where predicted value is categorical. Logistic regression is used for classification problems mainly. Here we are going to discuss binary classification. So first of all, you have to import pandas as PD, and you have to import matplotlib as well, because we will make some graph as well. When I will run it, you will see that it is executed successfully. Our next step is, we can wait, asterisk means it's working. Okay, so it's done now. So our next step is that we have to give some name to our data frame. I said insurance, right? Because we are working on insurance and age, so whatever name you want, you can give to your data frame, which is equal to pd.read underscore csv. Now, with the help of read underscore CSV, you can provide the path and quotation where your CSV file is located and executed. So see, it is executed successfully. Now we want to check whether our data frame is here or not. Just write down the name of your data frame and execute it. It's here. Exactly, you can see we have two columns, age and insurance. So randomly, if you will pick any number, you can see that 18 years, 0 means he or she will not take insurance. 37, yes. 45, yes, right? 35, yes. It means as the age increases, people prefer to buy the insurance. Okay, now if we will make some graph to show, so PLT, that is why we have imported matplotlib. We are going to make the graph between age and the insurance. plt.scatter insurance, right? See, this is insurance, name of our data frame, dot age. age is the independent variable, and independent variable we take on the x-axis. Insurance, y2 insurance, this insurance is my data frame name, and this which starts with the capital I, this insurance is my column, right? Run it, so you will see that this is our graph. This is the outlier. When you will join this according to sigmoid function, you will get S-shaped curve, right? And I had explained to you how it works. Now I will make this comment and remove this hashtag. So color is equal to green. It is not necessary that you can write down this syntax only. If you want, you can add some color, you can add some marker. I said marker is D means diamond, color is green, and then run it. So now you will see this, the same graph, but now instead of circle we have, by default it's circle, but if you want you can change your marker as well. But if you will join again, you will see S type curve, 2D curve. This is the outlier. Now you can play with it, make different colors, different markers. If you want to check the shape means it will show you number of rows and number of columns of your data set. So insurance, name of your data frame dot shape, and execute it. It means we have 26 records, 26 rows and 2 columns. Yes, we have 2 columns, age and insurance. It's all done. Now we are going to split our data frame, which is consists of 26 records. So training and test the data. Again, this topic we had discussed in our last lesson as well. You have to import train underscore test underscore split from sklearn. Now what will happen, we will split our 26 records, maybe 50-50%, it's up to you, 80% or 20%, 70% or 30%. So here I am going to split between 80 and 20%, 20% as a test and 80% as a training. I am going to train my data, and for 20% I will test my data. Now how to do? After this I will execute it. It's executed. See, asterisk means it's working. So we will discuss this. It's done now. See this one, the right hand side of this is exactly same what I have put a comment here only to show you how you have to write down train underscore test underscore split. This one, because we are going to split our data, this is my data frame name, this is the syntax. Age, right, you have to write down independent variable in 2D array. 2D array means you have to use 2 square bracket. Insurance dot insurance test size is 0.2 means 20%. Whatever is the 20% of 26 records, we will apply testing, and 80% is our train model, right? So exactly from here to here I have written in my second line, you can see here. But what output we will get, that is why I have made 2 lines, equal to x train comma x test, y train and y test. So first of all we will check x underscore train, right? I will execute this first, otherwise it will not work. Okay, x underscore train. So whatever is the 80% of 26 records, you will see here. So see, if you will count, these are not 26, this is the 80%, but it will not give the output of first 80% or the bottom 80%. Randomly it will pick 80%. So first he picked the, sorry, first the system picked 12th record, which is 36, and then 20th record 24, and so on. Similarly, if you want to check for y, just make it y, it will give you the output 80%. Randomly records 80%. 12 record 1 means he or she will buy the insurance. 24th record, she or she will not buy the insurance, right? Okay, now for the test, is whatever is 20% of the 26. So these are 1 2 3, only 6 records, 20% of 26, which so 8, 20 feet, again randomly it will pick, right? I am going to make it train here again because we will use test later on, right? So train is 80%, test is 20%. It's not necessary that you have to keep this ratio 30%, 70%, is up to you. Now here when we made our split. Here we have to import logistic regression and we have to create our object. So from sklearn you have to import logistic regression, and from this logistic regression we have to make our model object, sorry. So whatever name you will use here, same name we have to use in rest of our coding. So model is equal to logistic regression and then parenthesis, and then I'm going to run it. It is successfully executed. Now we have to fit our model. Here means dot fit function means that we are going to make our model and see it is successfully created. Now our test, again X test, which is the 20% of our record. So here is the 20% of our record. The system picked 8th record, 25th, 18, 10, 6 and 7. Now we are going to predict model.predict X test, right? What is the output? I will show you, then we will discuss. So see 1, 1, 1. What is the meaning of this 1, 1, 1? Means the first record is 30 years. He or she will buy the insurance? Yes. 1 means yes. 60 years? Yes. 43? Yes. Means all will buy the insurance. 1, 1, 1, 1, 1 means we have seen in our CSV file that as the age increases, starting from 17, 18, 19, 20, they will not buy the insurance. But see these, as the age increases, they will buy the insurance. So if you want to check the score, score means it will check that what is the relationship, how perfect your model is. When I will run it, it says 0.5. It means our model is 50% accurate, right? Is not 1 means each and every figure is correct, but it is 50-50%. So dot score, with the help of dot score you will find out what is the relationship between these two variables. So model dot predict in probability, in case of probability you have to write down dot predict underscore probability. Do not write down the complete word probability. X test, right? We are going to see these are the test values. Okay, first I will run, then I will show you what is the output. This is the output. See, first one, if the person is 30 years, what is the probability? First one will show they will not buy the insurance. So 0.34 means 34% is chances that that person is not buy the insurance. 65% is probability that he or she will buy the insurance. Check for this last one, 45. See, the age increases, the chances of buying the insurance is more. So 45 years means 13% probability that he will not buy the insurance, but there is 86% probability that he or she will buy the insurance. Take one more example, right? This is 28. We will check the second last. So what is the second last? 38% probability that he or she will not buy the insurance, but 61% probability that he or she will buy the insurance. So if you want, you can check dot predict underscore probability. The first one will show not not, and this will yes. So no and yes probability, right? Here if you want, you can use some age dot predict, in parenthesis we can write down 20 years. If the person is 20 years, he will buy or not. So answer is no, because it is young. Our data says as the age is less, he or she will not buy the insurance. I am going to make it 70, and when I will run it, so it is 1 means yes, he or she will buy. If I will make it 15, which is young again, the output should be 0. If I will make it 45, it should be 1, and which is 1. So see here, with the help of this model, we can check our test as well. So I hope that this topic, logistic regression, which is one of the most important topic in machine learning, is clear. So please practice it. See you in the next lesson, and thank you.